Hello, everybody. Welcome to this video on types of schedule in transaction processing of DBMS. So in our earlier videos, we have talked about transactions, and we have also talked about the need for concurrency control. So here, let us look at the different types of schedules that we can have of transactions. So what exactly is a schedule? So a schedule is nothing but a history of all transactions, and it is a way of ordering the operations that appear in the transaction. So it is an ordering, you can see the definition, it is an ordering of the operations of the transaction. So we can write it in different notations. One notation is like this, where SA is a schedule, where R1X belongs to transaction T1. Let's say transaction T1. It is a read operation, read data item X, and R2 denotes for transaction 2, read data item X for the different transactions. So the index or the prefix, it indicates which transaction. So I can have a schedule written like this. R1X means transaction R1, transaction T1, read, transaction T2, read X, followed by transaction T1 write X, followed by transaction T1 read Y, then transaction T2 write X, and transaction T1 write Y. So we can write a schedule like this, or we can define a schedule like this, which makes it more readable. So here we can see first is read transaction T1 performs a read item X, followed by some other local operation. Then the next instruction to be executed will come from transaction T2. It is also read item X, then some local operation. Then we go to transaction T1 again, which will write the data item X, followed by a read of data item Y. Then again, it will shift to transaction T2, which will execute write data item X. And then again, from here, we go back to transaction T1, some local operation, and then finally write item Y. So this is a schedule, and this shows an order in which the instructions in transactions work when we have an interleaved execution of the transactions. Now, when multiple transactions are executing at the same time concurrently, then there are said to be some conflicts. Two operations, some operations can be in conflict. So two operations in a schedule are said to conflict if they satisfy all three of the following conditions. So what are the conditions? First of all, they should belong to two different transactions. They access the same data item X, and at least one of them must be a write operation. So let's say I have transaction T1 and transaction T2. So here I have a read X, and here I have a read X. So are these two conflicting? Let's see, read and read. Okay, they belong to two different transactions. Yes, these two operations belong to two different transactions. Do they access the same data item? Yes, both of them works on the data item X. And the third condition is at least one of the two operations must be a write. So here you find both of them are read. So one is not a write. So the third condition is not satisfied. So these two operations are not conflicting operations. But if I have something like this here, write X. So again, now if we consider this and this, these two operations, let's say, so they belong to two different transactions. So first condition satisfied. They read or write the same data item. Yes, X. Now one of them is a write. One of them is a write. So these two operations now are said to be conflicting operations. So this is known as a read-write conflict. Now suppose I have one more operation here, write X. Okay, so now I consider these two these two operations, the writes. So I have write and write, both again belonging to two different transactions. They have accessing the same data item, and one of them, at least one of them, is a write. So both are write. So this is also a conflicting. These two are also conflicting operations. And this is known as a write-write conflict. So why do we need these conflicting operations? We'll see in a while that we can do some processing with these on schedules on these conflicting operations, and we can see that how we can assure that concurrency control is maintained. So this is about conflicting operations. So this is the example like I showed. So you can see, read both of these two. These are non-conflicting. So this and this is conflicting. This is conflicting. This is non-conflicting. So this one and this one, even though one is a write, but they're accessing the different data items, so they are non-conflicting. And this also, they are accessing the different data items, so they are non-conflicting. So that is about conflicting and non-conflicting operations. Now, another terminology that we're going to use here in schedule is that of a complete schedule. So what is a complete schedule? It is just a very basic definition of a schedule. So suppose you have a schedule of n transactions. Let us consider n is 2. So I have two transactions, T1 and T2. So for a complete schedule, we have these conditions. First one, the operations in S are exactly those operations in T1, T2, including a commit or abort operation as the last operation of every transaction. So we know that the last operation of any transaction is either a commit or an abort if there is a failure. So in the schedule, when we show the interleaving of the operations, then it must contain the same operations that are there in transaction T1 and T2. So if I have T1 has got read X, read Y, write X, and write Y. So these are my operations of T1, and in T2 I have read X and write X. And then of course here I may have a commit. Here also I may have a commit. Okay. So in the schedule, when we put T1 and T2, all these operations must be there. Read X, maybe read X, read Y, then write Y. Okay. Then I may have a write X here. Then I have a write Y here. Write Y, this is write X. And then here I have a commit for T2, and here I have a commit for T1. So this is a first condition. All the operations that were there in T1 are there in the schedule, and all the operations that are there in T2 are there in the schedule, including commit or abort if any. Then for any pair of operations from the same transaction, their relative order of appearance in S should be same as the operation in order of appearance in T1. So if, like here, we have written for T1, read X followed by read Y. So in our transaction T1, I have read X followed by read Y. So the order is maintained. I cannot change the order from read Y first and then read X. Okay, so the order must be maintained. Then comes, for any two conflicting operations, one of the two must occur before the other in the schedule. So I can see this could be a conflicting operation. These two are conflicting operations. Both are writing the data item X. So these two conflicting operations. So one must occur before the other. So here we have one must occur. The T1 is occurring first, followed by T2. So if I have a schedule like this is known as a complete schedule. Now here you note one point, that two non-conflicting operations to occur in the schedule without defining which one first occurs first. So here we are saying that if there are two conflicting operations, then one must occur before the other. but nothing is being said about the non-conflicting operations in the schedule. So that means for the non-conflicting operations, you need not have an order. There is no need to have an order. Okay, so that gives us that is going to give us some way by which we can think of looking at schedules for concurrency control. So this is a complete schedule. Now, we saw that in a previous lecture that systems may fail because of various reasons. And if there is a failure, then we need to recover from this failure. So based on this criteria of recoverability, okay, we can classify our transactions in a particular classification, in a particular order. So what we are saying here that for some schedule, it is easy to recover and from system failures. And whereas for others, it is more complex. Okay. In some cases, it is even not possible at all to recover after a failure. And one point to remember is that if your transaction is committed, you cannot roll back that transaction. You cannot undo the work done by that transaction. So once committed means permanent. But if it has not been committed, then you can always roll back or undo a failed transaction. So based on recoverability, whether this particular schedule can be recovered or not, we have a classification based on recoverability. So two types of schedule here we can classify: recoverable schedule and non-recoverable schedule. So the name itself tells you a lot about the type of schedule it is. So recoverable schedule is one where no transaction needs to be rolled back. Okay, so you have, if a transaction is failed, then only that transaction which failed has to be rolled back, but others need not be rolled back. So a schedule, the definition is a schedule S is recoverable if no transaction T in the schedule S commits until all transaction T dash that have written an item that T reads have committed. So what in brief, what it means is that if a transaction is a schedule is recoverable if there is no transaction T in S which reads from a data item from an uncommitted transaction. So it will read only from committed transactions. So I can give you I think I have an example here. No. So okay, so here I have T1 and T2. So I have read X, write X, okay, and then commit. Now T2 is also going to do a read X, okay, and some more. So here T2 is reading the value of X because the value of X was written by T1, okay. So any other transaction should be able to read the value of X only after T1 has committed. So if your schedule is like this for every data item and every read operation, then it is a recoverable schedule. And if not, it is obviously called a non-recoverable schedule, so which you cannot recover. Okay, so a schedule where a committed transaction may have to be rolled back during recovery is called non-recoverable because once it is committed, like I said, you cannot go back, you cannot undo the operation. So this will not be permitted by the DBMS. So such a schedule is a non-recoverable schedule. Now, obviously, we would like to have schedules which are recoverable. Okay, so our aim is to look for recoverable schedules, to allow only recoverable schedules. Now, sometimes when we are rolling back or we are undoing the operations of a transactions, or say read X, write X, let's say there's abort here and there is a failure. So what you'll have to do, you have to undo the operation of this, undo the operation of this. This is called a rollback. Now we can have, in a multi-transactional system, we can have cascading rollback when one transaction fails. So this transaction fails. Now, as a result of this failure, other transactions which are using, say, I have T2 and T3 also. Now, these operations also have to be rolled back because of some data which has been, because it has read here. I may have here read X. I may have here read X. Okay, both transaction T2 and T3 are trying to read the data item written by X. So as a result, X is going to be, this is going to be rolled back. So there is an undo here. So because it has read a value of T2 has read a value written by T1, so T2 also will have to be rolled back. Similarly, T3 will also have to be rolled back, and so on. So this is known as a cascading rollback. Now, obviously, we'd like to avoid cascading rollbacks. So like here, you can see T1, T2, T3, T4, and T5, 5 different transactions are there. You see, T2 is reading a value written by T1. Similarly, T3 is reading a value written by T2. T4 is reading a value written by T3, and T5 is reading a value written by T4. Now, if T1 fails, T2 also has to be rolled back because it has read a value written by T1. Now, if this value is going to be, you're going to undo this. This value will not be valid anymore. So T2 has to be rolled back. And again, T3, because T3 has read the value of A written by T2, so this also has to be rolled back, and so on. So this is an example of your cascading rollback. Now, as I said, we do not want cascading rollbacks. So we again another classification of schedules, that is cascadeless schedule and cascading schedule. So cascadeless schedule is one where every transaction reads only the items that are written by committed transactions. Written only by committed transactions. So in that case, you don't need to have your cascading rollback. And in case of cascading schedule, a cascading schedule is a schedule in which uncommitted transactions that read an item from a failed transaction must be rolled back. So if we see this, let me just rub, let's come back here. So here, if you see, this is a cascading schedule. This is a cascading schedule because if T1 fails, you have to roll back T2, T3, T4, and T5. So this is the cascading. But suppose there was a commit here, C1. Let's say C1 as commit 1. After that only, T2 reads the value. So it's committed means it is written permanently to the database. So even if it reads, it's okay because here, even if T1 fails, it has already committed, means whatever was supposed to be done by T1 has been done correctly. So we don't need to roll back T1, even if there is a failure in T1. Similarly, here, if there is a commit, okay, and then after that only that read is there, read is here after the commit. In that case, you don't need to, if T2 fails, you don't need to roll back T3. Similarly, T3 commit, this is commit, and this is commit. So other transaction, a cascadeless schedule would be one which reads from committed transactions only. So that is a cascadeless schedule. One, every transaction reads only the items that are written by committed transactions. So cascadeless schedule. So we do not want cascading schedules. We want cascadeless schedules. And finally, let us look at something which is known as a strict schedule. So we have, first we had this hierarchy, recoverable and non-recoverable. Okay, then we had cascading and non-cascading. And then we have one more type here known as, this is also actually a part of non-cascadeless or non-cascading or cascadeless. This is your strict schedule. A strict schedule. So strict schedule is more stricter than your cascadeless schedule. In cascadeless schedule, you cannot perform, you can only read, that reads only from committed transactions. Here it says a transaction can neither read or write a data item until the last transaction that wrote X has committed. So even stricter. So a transaction can neither read nor write a data item X until the last transaction that wrote X has committed. So if you look at this example, here T1 has performed a write A or write X, okay? Then there is a commit, okay? And T2 has to wait, cannot perform a read nor a write. It cannot do anything. It cannot do read A or write A until and unless T1 has committed, because T1 was the last one which performed a write on the data item A. So this is a strict schedule. So based on recoverability, we saw the types of schedules, the classification of schedules based on recoverability. We have recoverable schedules and non-recoverable schedules. And then we have, we have cascadeless schedule and cascading schedule. And then we also have strict schedule. So these are the classifications of schedules based on your recoverability. In the next video, we'll look at another classification of schedules, which will be based on a term called serializability.